Hey everyone! Today we are going to discuss about rational inequalities. But before we begin, I would like to give a shout out to Miss Ella for making the channel art for my YouTube channel. So thank you. So a rational inequality is composed of rational expressions combined with a greater than or equal to symbol, less than or equal to symbol, greater than or less than sign. So an example of a rational inequality is this one. X minus 2 over x plus 3 is greater than or equal to 0. So we can see here that we use the symbol here, greater than or equal to symbol. So our task for today is to find out what are the possible values of x's that will make this inequality true. Now take note that there will be more than one answer for this inequality. So we will express our answer as a solution set. So the first thing that we have to do is we have to make sure that the right side is 0. So if it's not 0, we have to manipulate the inequality so that it will become 0. So in our example here, the inequality's right side is already 0, so we have no problem with that. Now, next is we're going to get the critical numbers. To get the critical numbers, we are going to separate the fraction here into its numerator and denominator. So we have here the numerator and the other one is the denominator. There we go. So we're going to take the numerator, which is x minus 2, and the denominator x plus 3, and equate them both as 0. Then let's solve for x. So this becomes x equals 2, and x equals negative 3. These two values of x's are called critical numbers because they make the numerator and the denominator equal to 0. So this has a very important significance in our solution set later. Now, let's identify whether these critical numbers are included in our solution or not. For the denominator part, these are always not included. Not included in the solution set. Why so? Because if the denominator becomes 0, then the fraction here becomes undefined. Remember that a fraction is undefined if it's a number over 0. Any number divided by 0 is undefined. So we will not include solutions which makes the fraction undefined. So x equals negative 3 is not included. Now for the numerator, there is a rule to determine whether the numerator's critical number is a solution or not. If the symbol is greater than or equal to or less than or equal to, it is included. However, if the symbol is greater than or less than, it is not included. In our example here, the symbol is greater than or equal to. Therefore, we include that in our solution. So this is included. Now please remember this, we're going to use this later on. Now, our next step is to create a number line. So this is our number line. So this is 0 right here. And let's write down the critical numbers. Let's say that the negative 3 is right here to the left of 0, and 2 is somewhere here to the right of 0. Then we write here the two binomials, the x minus 2, the numerator, and the x plus 3, the denominator. By the way, this number line extends infinity to the left and to the right. So in this case, this number line extends infinitely to the left. That's why we have a negative infinity here. And it also extends infinitely to the right. So we have here the positive infinity. Now, we're going to get the critical numbers and we look for a binomial where when we substitute the critical number to its value of x, it would be 0. In this case, negative 3, when substituted here, this becomes 0. Negative 3 plus 3 is 0. So let's mark it right here. Right here. So this is 0. Now, all values to the left of 0 are all negative. So let's mark all of them are negative. And all values to the right of 0 are all positive. So let's mark it right here. Now, let's go to 2. When we substitute it here, 2 minus 2 becomes 0. So this becomes 0. And again, all values to the left of 0 are all negative. And all values to the right of 0 are all positive. Now, what's the significance of this? We're going to select regions because since we have now the signs here, we can separate the number line into several regions. So let me break it down here. The division is on the values of zeros. So we have three regions here, rather, the negative negative, the negative positive, and positive positive. Now, back in our given, let's remember that it's x minus 2 divided by x plus 3. So these are all the values of x minus 2, and these are all the values of x plus 3. So we are going to divide the signs. So negative divided by negative is positive. Negative divided by positive is negative. And positive divided by positive is positive. So there are three regions here, the positive, negative, and positive. So what are we going to do with this? Let's go back to our original given. Take note that this is a fraction which is greater than or equal to 0. So the numbers or the possible numbers that are greater than or equal to 0 are 1, 2, 3, 4, so on and so forth. So we're expecting that this x minus 2 over x plus 3 is a positive number, so it is greater than or equal to 0. So the region that we're just going to accept are those regions which expresses a positive answer, namely this region and this region. So the values right here are not solutions. So the numbers from 3 and negative 3 and 2 are not solutions. But let's check, is negative 3 a solution? We ruled out earlier that it is not a solution. But is 2 a solution? It is a solution. So let's label the sign here as a black dot. If it's a black dot, it's included. But if it's a hollow dot, it is not included. So how do we express our solution now? This is from, in this region, the negative infinity up to negative 3. Negative infinity, let's put a parenthesis here. And negative 3, it is not included, so we put a parenthesis here. We use parenthesis if the solution is not included. We use a brace if it's included. Now, for the second region, it is 2 up to positive infinity. Infinity, let's put a parenthesis here. Infinities, by the way, they always get a parenthesis. But for 2, it is included, so we put a brace. And we combine the two sets together with a union. So that's how we solve a rational inequality. For our next example, let's have x squared minus x minus 6 all over x plus 5 is less than 0. As we can observe here, the numerator this time is a quadratic expression. So we're gonna do something about it. Now, first thing that we have to observe is that the right side should be 0. In this case, it's already 0, so we have no problems with that. Now, we have to break down this quadratic expression into two binomials by factoring. Please review factoring. So let's have the binomials here. So factoring x squared minus x minus 6, x squared is x times x. The factors of negative 6 would be negative 3 and 2. And by performing FOIL, we know that the middle term would be negative x, because negative 3x, positive 2x, add them, negative x, all over x plus 5, which is less than 0. So let's have the table here. We have the numerator and we have the denominators. Observe that in our numerator we have 2 binomials. So we're going to get 2 critical numbers on the numerator and 1 critical number on the denominator. So let's have x minus 3 is equal to 0. X plus 2 is equal to 0. And x plus 5 is equal to 0. X minus 3 equals 0, that is x equals 3. X plus 2 equals 0 is x equals negative 2. And x plus 5 equals 0 is x equals negative 5. So these are our critical numbers. Now, are they all included? For denominators, it is not included. Remember that, huh? But for the numerator, since our symbol is less than 0, there's no equal there, we are not going to include them as well. So it is not included as well. So let's now make our number line. So here's our number line. Here's the 0 here. And remember, our critical numbers are 3, negative 2, and negative 5. So we have 3 critical numbers here. Negative 5, negative 2, and 3. And let's put the binomials as well. X minus 3. X plus 2 and x plus 5. And let's all write the signs that we have to have. So for negative 5, it's with x plus 5. So we'll put a dot. It's a hollow dot because remember that the critical numbers for both numerator and denominators are not included. Okay? So negative right here, positive right here. For negative 2, it's x plus 2. So 0 right here, negative, positive. And for the last one, we have x minus 3, and this 3 right here, it's going to be here. They're all hollowed because they're not going to be included. If it's included, it should be a solid dot, so we're going to shade what's inside if it's included, but in this case, it's not. So let's identify the regions. So let's put some dividing lines here. Actually, the 0 here is not important, but I write here so that we have a guide on where to put the negative and the positive. Now, so let's multiply negative, negative, that's positive, times negative, that will be negative. Negative times negative, positive, times positive, positive. Negative times positive, negative, times positive, negative again. Positive times positive, positive, times positive, positive again. So we have negative, positive, negative, positive. So what are we going to select here? If we go back to our given, it's less than 0. So what are the values less than 0? That's -1, -2, -3, so on and so forth. Therefore, we're going to select those regions which are negative, namely this region and this region. We do not accept these two. So our solution set would be from 5 going down to -infinity, and those numbers from -2 up to 3. But we do not include the critical numbers, remember that. So our solution set would be -infinity up to -5 parenthesis union -2 to 3. Both are all in parentheses. So that's how we solve rational inequalities. I hope you learned a lot today, and thank you guys for watching.